So with our unit test running, there's one last thing left to do. Every once in a while you want to run programs under different circumstances and then graphically show the results, for instance, like timing runs or something like this. In our particular case, we're going to use the example here for the unit tests to just get a bar graph plot of the passed versus failed versus skipped and blacklisted unit tests. To that end, in the project, we already have a file that actually does this plotting in the system here. So this is here in the test directory, ssntest.py. And this file is runs the unit test, just basically looks at the third to last line, splits it apart in the spaces, and then extracts the numbers from the reported totals, and then just plots those using a Python library called Matplotlib. As you can see here, we have no Python interpreter configured, so we need to do that first and also install Matplotlib. And we can conveniently do that from within CLion. So that's the first job. And then next step is to actually run this Python module to actually run the unit test execute. So let's do, however, first the configuration of the Python interpreter, which we'll do system-wide. So we can go into the CLion preferences. And so there are a couple of preferences here that you can set. And in our particular case, we want to log into build execution and deployment, and there is a setting here for the Python interpreter, which we'll pick now. So as you'll see, there is no interpreter available right now, but of course we have one because we installed one earlier. So let's try to show all interpreters, and we don't see any here, but we can add the system interpreter to it by clicking on the plus. And we give CLion, of course, access to all sorts of different folders here. And then we can use a virtual environment that is sometimes useful for content management systems like Django, but we actually want to use the system interpreter. So let's go ahead here and pick the system interpreter. And as you can see here, this is the one that we installed earlier, so that should be the right location for this. So for Python 3.8, let's go ahead and use this. And then hit OK. And what it does then, it actually goes through the installed Python modules, of which there are just two, and both of these are actually modules to install the other packages that are available to us via the Python package repositories. So both of these are actually out of date. As you can see here, these are updated on a regular basis separately from the Python base installation. So first thing we want is actually update those. So we can choose this and then hit the upgrade button, and that will upgrade the first tool, pip, which is for package installation, and then the setup tools are for package configuration. So and I'm going to do the same thing for the setup tools as well. So and doing this through CLion is a lot more convenient than trying to do this from the command line. And it's actually a nice way to see which packages need upgrades. So you can check they're actually on a semi-regular basis to see whether additional packages need to update. So the one package that we need is a very nice plotting library called Matplotlib, and we can install that package, search and install for the package by hitting the plus sign here. And this gives us everything that is in the Python package repository, and we just search for matplot lib, and we'll see that, of course, it shows up here. There are a couple of additional modules that are available here, but we'll just stick to the basics and just use the latest version of Matplotlib. Just like with Macports, this thing is a package management tool, so it actually automatically will track down and install the corresponding package dependencies. And so while this is working, we can actually already close this. And eventually we'll see when this is done that not only Matplotlib shows up, but some of the other packages that are needed as well. So Matplotlib is installed. We have a configured interpreter, so we can hit OK here. And we still don't have a Python interpreter for this particular module, and the reason for that is that we're not going to run this module in this directory. So the module, of course, needs access to the executable, which has been actually created in the build directory. So in the CMake file, we actually, for the test submodule, we actually say, well, copy over this test file into the build directory where the executable is actually being generated. And so when we open up the CMake build directory, we see that in the test subdirectory here, there indeed is the executable and there is the Python module. So we need to run this particular Python module. We can click, right-click on it, and that brings us to a context menu here, and there actually should be a option to run this. Check whether I have the right one here. Right click, and it looks like there is no here. Oh, the system is still configuring the Python system in the background. So that's what's going on here. Let's wait until this is finished and then see whether we get a option to actually run this. So background jobs are done. Let's go ahead and see. Now we see that the Python system has been scanned by CLion, and we actually now can run the module. And so a run configuration has been created for this, and we see that now it has been running, and then Matplotlib has created a bar graph for us that actually shows us that we have 64 tests passed and no skipped, failed, or blacklisted tests. So that's how the system is being configured for automatic execution of built executables with additional analysis of results and plotting of results using Python. And that completes our toolchain. So this should set you up for most of the assignments that you can face in curriculum.